architecture and a couple of two-tier architectures. First, let's consider Cisco's traditional three-tier architecture where we have an access layer, a distribution layer, and a core layer. Down at the access layer, that's where we're connecting out to end devices like PCs and laptops and printers and wireless access points. And it's common in a building that has different floors that we've got a set of access layer switches on each floor of that building. Maybe there's a wiring closet on each floor, and all of our devices on that floor, they home back to that wiring closet and they plug in to access layer switches. But within the building, we might have those wiring closets stacked. That's a common way of doing it. And we've got riser cable running from one floor to another floor to another floor. Well, all those floors, all those switches in the access layers, they home back to a building distribution layer switch. And at the distribution layer, we're interconnecting the access layer switches. And we're also providing a pathway to get out to the rest of the world, maybe other buildings in a campus environment, maybe out to the internet. And if we do have more than one building, let's say in a campus environment, a business campus or a university campus, we could interconnect our different buildings. Specifically, we can interconnect the different building distribution layers with a core layer. The core layer's primary concern is speed. It wants to get traffic as quickly as possible from one building distribution layer switch to another building distribution layer switch that might be in a different building. And it also can get us out to the internet or maybe over the IP WAN. But that's Cisco's traditional three-layer model. And if we take a look at the actual topologies involved here, we can see we've got a mixture. Think about it. We've got a star topology down at the access layer. We're starring out to all of those different devices. For redundancy, we're interconnecting our switches between our layers. That would be a partial mesh topology. And since we've got both a star and a partial mesh topology showing up here, we can call this a hybrid topology. It's a mixture of different topologies. But again, this is the traditional three-tier architecture. However, sometimes we don't have enough buildings to justify having separate core and distribution layers. Maybe we only have a single building. Maybe it's a SOHO environment, a small office, home office environment. In a case like that, we can take the responsibilities of the core and distribution layers and we can consolidate them into a collapsed core architecture. With a collapsed core, we combine the functions of the core and distribution layer switches. Specifically, this collapsed core, it can connect out to our access layer switches, and it can also get us out to the internet, and it can interconnect our different access layer switches. That's a collapsed core or a two-tier design. Another two-tier design I would want you to know about is often seen in data centers. It's a spine leaf design. And here we've got switches maybe within a rack, and those switches might be connecting to servers in that rack, and those servers are running some sort of hypervisor and they're running virtual machines. We'll say that the servers are the nodes here connecting into the leaf switches. And notice the redundancy. Each server connects into more than one of the leaf switches. And we might have, in this data center environment, we might have different racks, and we can have what's called a TOR switch, a top of rack switch that interconnects all the switches within that rack. That's an example of a spine switch. A spine switch is going to interconnect our leaf switches. Now notice what's happening here. Every leaf switch connects to every spine switch. That means if I want to go from one leaf switch to another leaf switch, maybe to go between servers, I only have to go through one spine switch maximum because I'm connected to every spine switch. And if we think about this two-tier architecture, this spine leaf design, logically, this is like having a single switch. You could think of that collection of spine switches as the backplane of our logical switch. And our leaf switches are much like the ports on our logical switch that connect out to our end devices. And again, this is commonly seen in data center environments to give us optimal traffic flow and lots of redundancy between our servers.